So initial velocity 10 meter per second, acceleration 10 meter per second square. Initially at t equals 0, body is at origin. Then we'll calculate at various instants of time what will be the velocity and what will be the position. What are the formulas I'm going to use? V equal to u plus at. So what is value of u? U is 10, a is 10, this is t. Similarly, s equal to ut plus of at square. This will be u is 10 t plus 10 by 2 t square. For all calculation purpose, and now we are going to study in detail what do you mean by accelerated motion. Uniform accelerated motion means what actually means. Okay, using these particular formulas, we are going to get the positions. Then from the position, we'll plot a graph, we'll study the motion, physical motion, how do it occur. So at t equals 0, it was at origin. What is the initial velocity of the object? The initial velocity of the object is 10. So let's enter all the data here. T equals 0. At t equals 0, the initial velocity of particle is 10 and it was at origin. At t equal to 1 second, it will be 20. And here how much it will be? 10 into 1. S1, let me calculate. 15 meter. T equal to 2, so this will be 30. S2 equal to 10 into 2 plus 5 into 2 square. So 20 plus 20, 40 meter. Distance covered is what we are checking. So 3 equal to, this will be 40. So now S3 will be 30 plus 5 into 15. This will be 75, 105 meter. Am I right? I think I'm in 75. Oh, yeah, 105. All these calculations correct. 420. First it will cover 15, next 25, 75. No, it should be. 4, it will be 50. S4 will be 10 into 4, 5 into 4 square. I think let me calculate all these things. If somebody helped, it would have been nice. Okay, anyway, let me try. 16 into 4, 16 into 5, 80. 120 meter. I think that 5, 3, 5. This 3 will be 9. No? 75 it should be. S5 will take it. $175 meter. One more last. 10 into 6. 60 plus 30, 5, 3, 15, 150. 36, no? So 36 into 5, 180. 180 plus 60. 240. Okay, this much of data will be sufficient. And we're like, this will be 5 position of this 120. For 5, it will be 175. For 6, it will be 240. $75. This I made change. S3 will be 75, 1575. Let me highlight. I'm 1575, 15, 40, 75, 120, 175, 240. Position of particle at various instants of time. Okay, we have to, again the same scooter, it is accelerating, the speed is increasing. Okay, I don't have time to draw the scooter. We will shift the data. All the calculations, what all we did, this one. Okay, this is a S equal to 0, it will be here. T code. The same thing earlier, what I did. Once again, I'm bringing so that you'll initial velocity, the scooter will start with initial velocity. Let me rearrange. Let me rearrange things. Oh, I think diagram. So now, so what we do is, I think I'm taking more time. Okay, just give me some time. I'll give a correct diagram. So the scooter is, yeah, on the road. Let's get into again the same set of the data, which at t equal to 0, it will be here, and s equal to 0. After 1 second, it will be at a distance of how much? It will be at a distance of 15 meters. 2 seconds, it will be at a distance of 40 meters. I should increase the distance. I don't have space. And then let me do like this. Yeah. 40. 1, 2, 3, 4, 5, 6. I need a lot of space. I think, yeah. One more. The distance between them will keep on increase here. I think I can take only till 5. That this will delete it. Not possible. Yeah, we can show things clearly. T equal to 1 second, it will be at a distance of 15 meters. T equal to 2 seconds, it will be at a distance of 40 meters. T equal to 3 seconds, it is a distance of 75 meters. T equal to 4 seconds, it is at a distance of 120 meters. T equal to 5 seconds, it is a distance of 175 meters. Whatever the distance covered in equal intervals of time, there's a main thing which I wanted to discuss here. Try to see that pink color arrows, the length of pink color arrows, it is increasing. Clearly, I'm showing in this situation. First 1 second, it will cover 15 meters. I'll make it plain so that you can see things clearly. Okay, next, how much it will cover? 25 meter. Sorry, 15. Okay, 25. Next again, between 3 and 2 seconds, it will cover 35, 45, 55 meter. I'll erase this data so that will not be under confusion. In what is the direction of acceleration? In what direction there's acceleration? The acceleration is in this direction. So in accelerated motion, what will happen to distance covered in equal intervals of time? Equal intervals. So there's a 1 second. So what are the intervals of time? Will be 1 second. So first you see this, the distance covered in first 1 second, 50 minutes. In the next second, it's covered 25. Next second, it covered 35. Next second, it covered 45. So in accelerated motion, what will happen to distance covered in equal intervals of time will keep on increase. I think there are some very important things which I'm going to conclude based on uniform accelerated motion. Distance covered, shall we put like this? Distance covered will increase in equal displacements. Means for equal intervals of time, the distance covered will increase. Okay, you can see this data. Here, this one. First 1 second, 50 meter. Next 1 second, 25. Next 1 second, 35. Next 1 second. So shall we put like this? Distance covered increases in equal intervals of time. There's the one statement. Then equal change in velocity produced in equal intervals of time. Okay, that already you can see that in 1 second, it will change from 10 to 20. Next second, 20 to 30. So equal change in velocity in equal intervals of time. But what point to distance covered will keep on increase. The difference of these two will keep on increase, you see. So shall we conclude some points here related to this? Just I wanted to give a description of this much only here. Graphically, we can show these things clearly here now. I think it is increasing, no? The way I'm showing it. So this will be delta T. T is in seconds and this S is in position. There's a position. Now look at this. This I'll indicate by delta S1, delta S2, delta S3. What happened? Delta S3, here it is delta S3 greater than delta S2 greater than delta S1. So what is the conclusion I can make it? Distance covered in equal intervals of time will increase with the time. Distance covered increases in equal intervals of time. In accelerated motion, distance covered increases, distance covered increases in equal intervals of time. There's the one first point. Equal change in velocity is produced in equal intervals of time. I think that already we have discussed. Equal change in velocity is produced in equal intervals of time. This is the one thing. Okay, this is about the graph. Can we put it graph in either way or only this condition? So now can we put it equal displacements? We'll see what will happen. The same graph. Let me draw the fresh one. The same s equal to t square, so that equation is what plotted here. Now we'll take the equal displacements. So the pink color lines will be of equal displacements. I'm trying my level best to give a suitable graph. The spacing between the lines, pair of lines will be same. The equal intervals of time is what I picked up. Okay, let's see what will happen to this. Are you noticing anything very good difference? So the delta S is same. What about delta T1? This is going to be different. Delta T1, delta T2, delta T3. Look at that interval. This is T is in seconds. This is S is in meter. This is a position. This is all for uniform accelerated motion. Everything I'm discussing. So look at the graph. What is S equal to 10t? For accelerated motion, it is all. So what is the condition we can put it here? Time interval for successive equal displacement decreases. Time interval. So what is the data? We can write it one more. Time interval for successive equal displacements decreases. So for first, like it's having displacement, it moves from say like a 0 to 5 meter, next again 5 to 10 meter, then again 10 to 15. What about time taken? Will keep on decrease here. Time interval for successive equal displacement decreases. There's a one thing. Okay, let's talk about the what will happen to the average velocity. Average velocity. Anything can we conclude about the average velocity? If I calculate average velocity here, so what you can write, average velocity will keep on increase, no? In accelerated motion, average velocity for equal intervals of time. So delta S1 will be greater than delta S2. So let me write one more here. One more data, looking at this. V average 1, delta S1 by delta T. V average 2, delta S2 by delta T. V average 3, delta S3 by delta 3. We know delta S1 so V average 3 greater than V average 2 greater than V average 1. For equal intervals of time, what will happen to average velocity will keep on increase. So what is the equation? We can write it here. Average velocity taken over equal intervals of time will increase. Average velocity taken over an equal intervals of time increases during accelerated motion. One more, very important. I think I have brought very good equations from here only. You can see that. or else you can take help of this also. So for all this is very important. Accelerated motion distance covered increases in equal interval. In first second, it will cover some distance. This is very important. You see, in first second, 15 meters. Next second, it will cover more. In the next second, it will cover more. 0 to 1 second, it will move 15 meters. Then 1 second to 2 seconds, it will move 25 meters. 2 seconds to 3 seconds, it will move 35 meters. 3 seconds to 4 seconds, it will move 45 meters. This is what happens in uniform accelerated motion. That we are showing graphically. There's interpretation done graphically. Okay, after this, we'll take the next uniform retarding motion.